All right, looking at number 9 on dividing square roots, I have 2 times the square root of 3 all over 2 times the square root of 12. All right, so the square root of 3 is a prime number, so it doesn't break down into any factors. All right, now 12 has a couple of things it can break down into, right? But I'm going to be looking for the perfect squares if I can find them, right? Because it can break down into 6 and 2, but I'm going to be looking for those perfect squares. So just going ahead and keeping the 2 times the square root of 3 on top, 2 times the square root of 4 times 3, all right? Because I want to use that perfect square. I want to use 4 and not 6 times 2. I want 4 times 3. All right, 2 times the square root of 3 all over 2 times the square root of 4 times the square root of 3. All right, so I took them and I put them under each of their own houses, which once again is lovely because look at that. I can go ahead and cross out top and bottom. Square root of 3 goes bye-bye. And not just that, but look at this. There's a 2 top and bottom that I can nicely cross out also. And you could have done this at an earlier stage if you wanted to. Now remember, these are going to the number 1. So while both of the square root of 3 and 2 have been crossed out, they are both 1 now. So I can go ahead and put 1 on the top of my fraction, okay? Because I actually have 1 times 1, okay? And then I technically have 1 times the square root of 4 times 1, which gives me the square root of 4. All right, and the square root of 4 is, well, technically plus or minus 2, but they're only using the positive, and so we get the answer of 1